Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant updates.
Surface chemistry. From the name itself, the first thing that will strike is the chemistry related with surface. Now there are many processes in our day-to-day life which are related with the chemical processes occurring at the surface. Example, purification of water. In purification of water, the impurities are removed and they are accumulated on the surface of some substance. What substance it is, we'll talk on it later on. So purification of water involves a chemical process at the surface. Softening of hard water involves the removal of calcium and magnesium ions. Similarly, cleansing of the cloths involves removing of dirt or germs from the cloths. And all these processes are related with the reaction occurring at the surface. So these processes which I have just named, they can be referred as surface mediated chemical process. Surface mediated chemical processes. The name refers to the chemical reactions in these processes occurring at the surface. Now surface is a very common term, but if I ask you to define it, how can you define a surface? Any surface? The top part of any substance. More specific. And that layer is separating two phases. Correct? If I say this surface of the bench, this surface is being separated by the wooden part and the air. Correct? So, in general, a surface is a boundary between two bulk phases, which can be solid, liquid or gas. For example, commonly, the surfaces which we will discuss, let us say I have an insoluble solid which is dissolved in a liquid. Insoluble solid dissolved in a liquid. So this boundary which separates the solid and liquid is called as surface. Correct? And there can be reaction which can occur at the surface, and that part is basically discussed in surface chemistry. Similarly, if I have two immiscible liquids like oil and water, then the boundary separating the oil and water or two liquids which are immiscible is again the surface. There can be a possibility that I have a gas or the molecules of the gas which are enclosed along with some solid. Correct? So again, there is a boundary which is separating the solid with the gas, and this boundary is also called as surface. Clear? So the surfaces are indicated by putting a hyphen between the two phases. Meaning this surface can be indicated as S-L, meaning solid liquid, or it can also be represented as S/L. This is the convention, remember. S-L refers the surface is between the solid and the liquid. The hyphen or the slash indicates the surface or the separation. Clear? This can be referred as liquid, and this can be referred as solid gas. Understood? So surface is simply defined as a boundary or a separation between two bulk phases of the substance, which can be solid, liquids or gas. Clear? Now why are we studying surface chemistry? There are many processes which can be understood with the help of the surface reactions, like crystallization process, the crystallization of sugar, dissolution, wherein one substance dissolves into another substance, corrosion, the process of rusting of iron, catalysis, the working of the catalyst. All these processes involve the reaction at the surface. That is the reason we are understanding this branch of physical chemistry, which is dealing with the chemical reactions occurring at the surface, and the whole chemistry behind the surface reaction is referred as surface chemistry. So many such processes which I have named are related with surface reaction. Once again, I'll repeat that: crystallization of sugar, dissolution, the solubility of one substance into the other, corrosion, rusting of iron, catalysis, working of the catalyst, purification of water, which I named in the start, softening of hard water, cleansing of the cloths. Correct. All these are related with the reactions taking place at the surface. Correct. Now, why the reaction occurs at the surface?
Direct contact.
A direct contact? Yes. But what is the reason? Let's say I have a liquid which is placed in a beaker, and I consider two molecules in this case. One which is present at the surface, I call it as surface molecule, and one which is present in the bulk, which is called as bulk molecule. It is observed that the behavior of these two molecules is different, and this I have already discussed in one of the property of liquid. Very good. And that property of liquid related with this concept was surface tension. Surface tension was a property of liquid which was related to a process happening at the surface. So why the surface reaction occur? The question is that if I talk about the molecule in the bulk, it is attracted by the molecules in all the directions. Hence the net force acting on this molecule in the bulk is 0. But if I talk about surface molecule, it is attracted by the molecules to the side and below it, but there are no molecules above the surface molecule. So there is a net force which is acting downward in this case, and I can say the forces of attraction are remaining unbalanced. Now since there are unbalanced forces, this molecule would be unstable, and to become stable it needs to balance the forces of attraction, and that forces of attraction could be balanced by attracting the molecules which are present in its vicinity. So what it will try to do is, it will try to gather or accumulate the molecule on the surface so that the forces of attraction are balanced and the molecule will become stable, hence by lowering the energy. Understood? So the surface reaction take place because of the unbalanced attractive forces acting on the surface molecule. And this process in which molecules of one substance accumulate on the surface of another substance is called adsorption. It's called as adsorption. And this term I have discussed before. Very good. Hydrogen and nickel. We had done the hydrogenation reaction in case of unsaturated hydrocarbons. The example was alkene like ethene added with hydrogen in the presence of nickel gets hydrogenated to form an alkane. I discussed the mechanism here. What happens? The hydrogen gas molecules get not filled, accumulated on the surface of nickel, due to which the molecules on the surface will increase, and hence the rate of the reaction will increase, and that's what the catalyst does, increases the rate of reaction. So one of the example of adsorption was related with the accumulation of hydrogen on the surface of nickel. Why that happens? Because the nickel surface molecules will have some free valencies or the unbalanced forces of attraction, which it will try to balance by accumulating the molecules onto the surface, and that accumulation is in turn called as adsorption. Clear? Now understand few definitions. The molecules which are getting adsorbed on the surface are called adsorbate molecules. Are called adsorbate molecules. And the surface onto which they adsorb is called adsorbent. Surface onto which they adsorb is called adsorbent. So let's say these are oxygen gas molecules which are adsorbing in a particular liquid. Then the gas will be called as adsorbate and the liquid surface will be called as adsorbent, and the type of adsorption will be written as liquid gas, L-G. Clear? I not mentioned here, but this will be an example of liquid and gas adsorption. Clear? So adsorbate are the molecules which are adsorbed on the surface, and adsorbent is the surface on which the molecules are getting adsorbed. And the statement we say is the gas molecules are adsorbed on the surface of adsorbent. Clear? Now, if the molecules are removed from the surface, फिर से unbalance हो जाएगा, and that process is a reverse process which is called desorption. Adsorption meaning accumulation, desorption meaning removal. We have already named this type of words: hydrogenation, dehydrogenation, hydration, dehydration. The word D refers to the removal. So removal of the molecules from the surface is called as desorption. Clear? Now when the adsorption happens between the gas and the solid, that type of adsorption is given a special name called occlusion. You have to just remember this name. It's nothing but adsorption only, but whenever the gas is adsorbed on the surface of solid, the adsorption is simply referred as occlusion. Meaning hydrogen on Rani nickel is a case of occlusion. Remember this term. Clear? So the definitions which I have discussed is adsorption, adsorbate, adsorbent, the reverse process called desorption, and a special case called occlusion. Clear? Now, since adsorption happens at the surface, on what parameter would it depend? On the surface area. So, extent of adsorption would be proportional or dependent on surface area. And which substances have a large surface area? Which substances have a large surface area? If I take a solid substance and I take the finely divided powder of that same substance, a solid substance and finely divided powder, which will have a large surface area? Amorphous form. Finely divided powder, ज़्यादा surface area. Correct? मतलब, if I talk about charcoal, charcoal is porous in nature. Correct? And it also has a large surface area. Porous होने की वजह से क्या होगा? It will try to accumulate or adsorb the molecules onto its surface. So it is considered to be a good adsorbent. Likewise, you must have heard about silica gel. Whenever you purchase new materials or electronic items, that always have a pouch which contains small balls. That balls are made up of silica. Silica gel बोलते हैं उसको. ठीक है? वो क्या करते हैं? Absorbs moisture. Very good. It's not absorb, it is actually adsorb. It is not absorb, it is adsorb. I'll just talk about the difference between the two words. So what silica gel does is it accumulates the water molecules from the moist air onto the surface. It adsorbs the water molecules. Correct? Heard about anhydrous calcium chloride? CaCl2? क्या काम है उसका? It's a dehydrating agent. मतलब क्या करता है वो पानी को निकालता है. कैसे निकालता है? Absorb करके. अब यहाँ पे क्या करता है वो? Absorb करता है. Anhydrous calcium chloride absorbs the water molecule. Silica gel adsorbs the water molecule. Now what is the difference? Very good. एक सरफेस पे रहता है और एक बल्क के अंदर जाता है. मतलब डायग्रामेटिकली इफ आई शो यू, देन एडसॉर्प्शन में द मॉलिक्यूल्स आर रिटेन्ड ऑन द surface but do not enter the bulk, correct? But in case of absorption, the molecules would enter the bulk. So this is adsorption and this is absorption. Understood? Clear? So we say adsorption is a surface phenomena because the molecules are retained on the surface. Absorption is a bulk phenomena because the molecules penetrate inside the bulk. So simple एक word में अगर मैं लिखूं तो adsorption is accumulation but absorption is penetration. Here the accumulation happens at the surface, so it's a surface phenomena, and here the penetration occurs in the bulk, so it's a bulk phenomena. Clear? There are many examples in which adsorption and absorption may occur simultaneously. When these two processes occur simultaneously, then we just use a word sorption. Sorption is a process in which adsorption and absorption occur simultaneously. अब इसका एक बेस्ट एग्जाम्पल, अगर चौक को इंक में डिप करते हैं, if we dip the chalk into ink, blue colored ink, ठीक है, या कोई भी colored ink, ठीक है, एंड उसको निकालने के बाद क्या ऑब्जर्वेशन होता है? या सरफेस पे कलर होता है, और एंड इफ आई ब्रेक द chalk internally, what do you observe here then? Blue color is penetrated inside also? No. Blue color is only at the surface. Internally it becomes moist. Internally it becomes moist. मतलब जब चौक को इंक में डिप करते हैं तो the colored pigment are adsorbed on the surface, but the solvent of the ink gets absorbed into the bulk. Clear? The ink molecules or the pigments are accumulated on the surface. That's why it becomes blue colored, or the color of the ink is retained on the surface, and the solvent from the ink is getting penetrated or absorbed into the bulk. That is why the internal part becomes moist. Hence, this is a case of sorption where adsorption and absorption have taken place simultaneously. Am I clear with this? And the difference is very clear because silica gel and anhydrous CaCl2, मैंने ये बताया आपको. सिलिका जेल में क्या होता है? वाटर मॉलिक्यूल्स एडसॉर्ब होते हैं, और एनहाइड्रस CaCl2 में वाटर के मॉलिक्यूल्स एब्सॉर्ब होते हैं, पेनिट्रेट होते हैं. समझ में आया? ठीक है. ऐसे बहुत पोरस सब्सटेंसेस है जिसमें सॉप्शन हो सकता है, जैसे कॉटन फाइबर. कॉटन पोरस होता है. इवन इफ द कॉटन इज डिसॉल्व्ड इन अ इंक or any dye, so color pigment of the dye will get accumulated and the solvent will get absorbed. तो वो moist होता है because of absorption, वो color retain करता है because of adsorption. So cotton fiber also have the property of sorption similar to chalk dipped in ink. ठीक है. Now what are the examples of adsorbents? एक तो मैंने अभी बात किया, चारकोल. इनफैक्ट चारकोल इज द मोस्ट कॉमनली यूज्ड एडसॉर्बेंट इन मेनी ऑफ द इंडस्ट्रियल प्रोसेसेस बिकॉज चारकोल हैज अ लार्ज सरफेस एरिया एंड इट इज पोरस, सो इट कैन अक्यूमुलेट द डिफरेंट पार्टिकल्स ऑन टू द सरफेस. इट्स अ वेरी गुड एडसॉर्बेंट. इनफैक्ट चारकोल के बहुत सारे वेराइटीज भी एग्जिस्ट करते हैं, लाइक एक्टिवेटेड चारकोल, लैम्प ब्लैक, carbon black. Heard of this? So there are various varieties of charcoal, but as a family we can say it's basically the charcoal which is acting as a good adsorbent. Next example which I discussed was silica gel, which we use as a dehumidifier या ह्यूमिडिटी कंट्रोल के लिए, बराबर. तो बहुत सारे ऐसे क्यूबिकल्स भी रहते हैं या प्लेसेस रहते हैं वेयर वी डोंट वांट द मॉइस्चर टू एंटर इन दैट स्पेस, like it can damage the electronic items related with the servers. So that part needs to be devoid of moisture. So in that case we use the adsorbents like silica gel, which can absorb the moisture and make the air dry. ठीक है. Like silica gel we also have alumina gel, Al2O3. Even that is a good adsorbent. Now alumina can adsorb as well as absorb, meaning it is actually the property of sorption. Clear? Likewise, clay is also a good adsorbent because of its porous nature, similar to charcoal. The examples of adsorption on an industrial level. The first application is production of high vacuum. Production of high vacuum. So let's say there is a container which is connected to a vacuum pump. What will it do? It will suck the air and make the flask devoid of air. But there is a possibility that 1 or 2% of the gas molecules of the air retain or remain in the flask. So in that case what is done is that flask is also connected to a charcoal bulb. मतलब a bulb or a फ्लास्क कंटेनिंग चारकोल. अब चारकोल क्या करेगा? एयर के मॉलिक्यूल्स को एब्जॉर्ब कर लेगा. तो जितना भी बचा कुचा रिमेनिंग मॉलिक्यूल्स है जो वैक्यूम से नहीं निकला है वो सारा एब्जॉर्ब हो जाएगा एंड द फ्लास्क वुड बी नाउ विथ 100% वैक्यूम. सो हाई वैक्यूम प्रोडक्शन कुड बी अचीव्ड बाय द कॉन्सेप्ट ऑफ एडसॉर्प्शन. Adsorption is also used in gas mask, which the miners use. तो गैस मास्क के अंदर एक्चुअली क्या होता है? एक्टिवेटेड चारकोल. वो चारकोल क्या करता है? इट हैज द प्रॉपर्टी टू एडसॉर्ब द पार्टिकुलेट मैटर और द पॉइजनस गैसेस विच आर प्रेजेंट इन द सराउंडिंग विसिनिटी. सो वो सारे गैसेस और पार्टिकुलेट मैटर जो होते हैं जिसको पीएम बोलते हैं, and there are numbers given to these polluted materials, PM, particulate matter. ठीक है. So the charcoal have the property, a good property, to absorb all the particulate matter or the poisonous gases, and it will allow only the fresh air to flow through it. It is also used in purification of raw sugar or water. Now sugar जब cane sugar से prepare किया जाता है, it has many of the undesirable impurities which may be colored also. बराबर. So when this aqueous solution of raw sugar is passed through an adsorbent, what will it do? The particles or the impurities, colored impurities, will get adsorbed. And जब उसको filter करेंगे तो solution now will be colorless because all the colored impurities have got adsorbed onto the surface of the adsorbent. Again, in that case, charcoal is the common adsorbent used. Clear? This is also used in purification of water. You must have heard about alum. Now, the surface of alum also is porous, so it will accumulate the impurities onto the surface and thereby purify the water. Are you clear with that? I have also talked about humidity control, in which silica gel is used. Humidity control. Clear? And there are likewise many examples wherein adsorption is used on the industrial level.